It's time for us to talk some real serious TypeScript types, and in this section we will talk about some advanced types. This is the point where maybe if you already work with TypeScript, this is the point where you will want to take this course. Well, basically what we will do is take some existing types and create types from types using generics. This is what we will do in a few words. And here in the presentation you will see what kinds of types we will see, like read-only, like index signatures, different techniques to create some advanced types like map types. We will in the end talk about some built-in utility types, very handy from TypeScript. And in the last lecture of this session we will have a practice session, and we will create ourselves some advanced types. This being said, let's get to work and create and learn about some serious, more complex types. In this lecture, we will see how immutability works in JavaScript and TypeScript, and we will see how TypeScript assists us with this topic. Well, what it means to be immutable? Well, it means that, in a few words, that once created, it cannot be changed. And let's see this in two examples. First of all, we have a string and then an object. In JavaScript, strings are immutable and objects are not immutable. And let's see what this means. I have created here a variable called CEO and I have assigned it a string value. If this CEO is a let, then I can simply assign it to something else, right? I can say right here Bill with no problem. And the reason I can do this and TypeScript allows me to do this is because the type of this CEO is simply string. But if I will change the type of this CEO to const, then the type of this CEO will not be string, it will be the string literal Jeff. So this will be a compilation error. Yeah, this means that this CEO variable right now is immutable, and this is a string. In this way, strings are immutable in JavaScript. But what can we say about objects? Here I have created a CEO object, and as you can see, the name is string and the company is string. Well, I cannot reassign this variable. I can't just say right here that CEO object is something else. This is a compilation error. But what I can do, because objects are not immutable, I can say right here that CEO.name is Bill. And this is very valid TypeScript code. Well, how can I make sure that maybe my objects are very important and I don't want them to be modified after they are created? Well, TypeScript allows me to call as const after I created an object. And let's now look at how the types of this object look. And as you can see, now the values of the CEO objects are read-only. And I can make the whole object read-only, or I can only make parts of it read-only. I can now make, for example, only the name will be the string literal Jeff, and the company will be a random string. This means that I can change the company to something else. So this is valid TypeScript. Let's see another way in which we can use these read-only values. Let me make this back. So you saw how this asConst works. Let's see an example with a function. Well, I have here a function which receives an argument of type string array, and it returns a new array that contains the values of the original array but to uppercase. Very simple until now. The thing about this function is that it returns a new array, so we don't have any problems right here. But what happens if I will inside this function also try to mess up with this array? I can say here that names push, and I can push my name right here. Well, at this point I'm also tampering with this array, and yes, again I'm returning a new array, but this original array which I'm passing to this function will be modified. If I want to make sure that my function doesn't change what it receives, again I can make this the type of the arguments, I can make them read-only like this. And now if I want to call a method on this string array, read-only string array, TypeScript will complain that, and it will tell us that this property push doesn't exist on this type read-only string. So this is a way again in which read-only works in TypeScript. And let's see a final way in which read-only works with a small example which really gave me a hard time when I was learning TypeScript. So let's make some room and let's add a new example right here. And we have again the classic example with an employee and with a position and with a function that accepts an argument of type employee. Well, let's look at this function. It receives an argument of type employee, and let's look at this constant. It is exactly the same, it has the same structure as a regular employee, but the position is hard-coded, you know, is like this programmer. Well, if I want to call right here pay salary, let me comment this out and I can say here pay salary, and this receives John. What do you think? Pause the video for a few moments and think about, will this work or not, since John is for sure of type employee, but we didn't specifically said that. Well, will this work or not? Well, let's see if it will work. I tell you it won't, and let's see why. The type of this John constant is name and position, name of type string and position of type string. What problem will TypeScript rise? It will tell us that the type string is not assignable to the type position. Well, how we can understand this error, since for sure the position of this variable right here is programmer. And the reason TypeScript doesn't allow us to do this is because even if we have this object created right here, later on we can just call right here John, and we can say the position to be a position that we don't have inside our company, and this will cause problems. If we want to get rid of this error right here and to make sure that John can be accepted in this pay salary, we have two options. Either we specifically say that the type of this variable right here is employee, like this, and now the function will work, or we have another approach. We can make this object right here as const. And at this point, this will work, because at this point, you know, the position of this variable right here will be for sure programmer, and it can't be changed in the future. Regarding this read-only, I have one last point I want to make about generics. We can have this read-only string, but also read-only string array, but TypeScript also gives us a few utility types. We can have here a read-only array of string. It will be exactly the same thing, but this is like a more verbose way in which we can do it using generics. Well, we saw in this lecture how const and read-only work in TypeScript. Let's move on into the next lecture and talk about records. In this lecture, we will talk about index signatures and records, and to understand what they are and why we need them, let's look at this basic example. We have an type employee and a constant of type employee, which we are just giving itself names. Well, what happens if we want to extend this object right here? Let's say that this particular employee called John, maybe he has a very special email and we want to specify it right here. Well, what can we say right here? I can say email, and let's just say that the email of this employee. Well, TypeScript won't let us do this because it will tell us that this email doesn't exist on this type. Fair enough. Well, we can just say here that this employee also can have a field of type email, and that would be working. But let's say that we want to make a generic way in which we can extend our objects. We can do this with a method called index signatures, and in TypeScript we can do this with this syntax. We have here a key of type string, and this accepts a string value. And at this point our object is fully extendable with other fields of which keys are strings and values are strings. This means that at this point we can also have an age right here, and notice If I want to give it an age which is not of type string, because the value of these keys should be string, well, I will have a compilation error. If I will also want to accept numbers right here, I can specifically say right here key, string or number, and this way my object is extendable with index signatures. These index signatures are also used when we are building dictionaries, and let's see another example. Let's say that we have some sort of database type which receives, based on a key, it receives an argument. So here we have a list of employees which has this key and which has this value right here. And one way in which we can do this is by using these index signatures, or by using another special type from TypeScript called record. Instead of building a whole new type like I did before, which accepts a key of type string and then a value of type employee, what I can do is I can create a record which accepts keys and employees, and I don't need a new type for this. I can even comment this out, and I don't need this right here, you know, because I have these types right here. How can I access these values of these employees records? Well, I can just say right here const my employee is my employee records, and then I can directly pass its key right here, and for sure I will get my value John, or undefined, of course, if this field doesn't exist. Let's see another way in which we can use records, maybe a more clearer way in which you can understand how records work, and we can use it to build new complex types from simple existing types. Let's see an example. Well, let's see that we have 3 types of positions inside our company: a programmer, a manager, or an HR. And we want to have a type called position salaries, which accepts arguments of type positions and salary objects. How would an object of this type would look like? Well, if I want to create a type from this position enumeration right here, I can use it as a record, and as you can see, I can get content assist right here. I can specify a salary for a manager, and I can specify for it an object, a salary, exactly like this. And of course, all of them have the same salary. We don't want any problems within our employees. Well, this gives us type safety in the way that if we have new positions inside our company, maybe we want to have a position for a Scrum Master right here, we will have here a compilation error because it will tell us that Scrum Master is missing. Well, and I specifically added a space right here, and as you can see, we have a space right here, so I can't just say Scrum Master with, you know, without space right here. You know, JavaScript doesn't work like this. It won't know it from with spaces. So the way I can fix this is by using a string literal, of course, like this. And again, I can assign it now a salary, of course, the same salary. We don't have any problems. We don't want any problems between our employees. Well, our employees are happy, and they are happy because records saved us, and all our positions have assigned salaries. That's great. So we quickly saw in this lecture how we can use this record utility type from TypeScript. Let's move on into the next lecture and talk about the key of operator. A great TypeScript utility that will help you build very complex types, usually in combination with generics, is the key of operator. And at its basics, it is a very simple concept. If we look at the basic example that we have on the screen, you will see that we have 2 types, a position type, which is a string literal union, and a simple employee type. Well, we can use the key of operator to get the key of different types. So the key of operator only works on other types. Well, as you can see right here at line 10, we have a type employee keys, which is key of employee. This means that it will be exactly the same as I would write a string union type of name and position, the keys of this type employee. Fair enough, until now a very basic example. Let's complicate things a little, and then in the end of the lecture we will complicate things a lot. Let's use this in a combination with some functions. And let's just say that we have one initial employee called John. He has the name John and the position programmer. Alright, we can access the values of this John employee either by directly pointing them with the dot notation or by using John as an array. Simple until now, but let's do this inside a function. And let's say that we have a function called getProperty, and this getProperty function receives an argument of type employee and a key of string. And basically we want to print out what we get and return it back. Maybe this function receives a much more complicated object and we just want to get a very simple part of it. Well, but TypeScript is at this point screaming at us because it will tell us that it's not sure that this key right here exists on this employee, since inside this key we can pass anything. Well, to get rid of this error, we can simply say right here any, and we can use this function. Very simple. We can use this function and we can get the property of John. I can say right here that John's name is getProperty, and we want to get the property from John, and we want to get the name, and we should receive a string. Well, we can't know what we are getting because we don't have any type annotations in this function. Well, let's give it another chance, and let's use now the key of and some generics. So I will just make this a getProperty2 and build another version of this function. Well, I have built another version of this function, but let's do it by using generics. And let's say that we can build a function, since we are just getting object keys, we can build a generic function. So this getProperty should first receive an argument of type t, and our argument should be of type t. Well, the key of our object should be a key of this type t. So here I can just say, or I can just say right here, key of type, key of t. And everything should be alright until now. Let's not return anything at this point. Well, if we do it like this, then TypeScript will be just happy, because at this point TypeScript knows for sure that we can use this function only with the appropriate type of keys. For example, in this case, if we want to get the age of John, since it doesn't have this field, we will have a compilation error. But there's still something missing inside this function. You'll see that this John's name is of type string because we are accessing it right here, but we can take this to the next level and make this function really verbose. And let's just save this key of right here inside the generic declaration. And let's just say that this key extends key of t, and then we can use it in the method return type, and here we can just say that this function returns t of key right here, key of type k right here, and now our function also have a very verbose return type. Let's end this lecture with a more complicated example. Let's do a simple exercise. Let me comment this out, and let's have a function that returns the keys of an object. We can do it very simple with a utility from JavaScript called object.keys, and this is very straightforward. It just receives an argument and returns a string array with the keys of that argument. Very basic until now, but let's make things a little more complicated, and since we are using TypeScript, we want to get some strong types from this function, and let's do this with some more complex generics. Because what's the problem with this implementation? Well, if I can just say it right here, some keys is our get object keys, and I will just pass right here an empty array. For sure, I should know that this empty array will return an empty array, but the type of these sum keys at this point is a string array. Is there a way in which I can get a more early heads up from TypeScript that this is an empty array? Yes, I can do, and let's write this function with some more complex generics. So I will just copy and paste this. I will call it getObjectKeys without the to, and let's now also specify the return type. And the return type of this should be an array that contains key of t. And this should work. At this point, this SomeKeys is still of type string, because here we are having a compilation error. It tells us that type string is not assignable to type never, and this is because we can access or we can assign to this function some empty arrays. Well, we can fix this problem by using the record utility type that we saw in the last lecture. Well, here we want to have objects or records, right here, record, that have string of 4 keys and any 4 values. And at this point, we have a very complex function. Now, if I will use the other function, if I will look at these SomeKeys, then I will know that this is an empty array of never. In the same time, if I will pass some valid object, I will have this, for example, I will pass an object with some valid keys. If I will hover over it, TypeScript will directly know, without executing my code, that this is a one element array which is ABC, because this key of, happens at compile time, and TypeScript is able to tell us from the head start what the values of these functions are. Well, we saw in this lecture some simple example with key of, but we also saw it so that we can combine it with more complex features of TypeScript to get some very complex types and also return types for functions. Let's now learn about TypeScript conditional types. And to understand them, we first need to remember how the JavaScript conditional or ternary operator works. For example, here I have a simple function that returns a Boolean value, a function that checks if a salary is big. Well, we can calculate the bonus based on the salary, and we can pass this, we can use this ternary operator when we are assigning this bonus variable. Well, this is called the ternary operator because there are 3 parts inside this condition. Here we have a condition which returns a truthly or falsy value. If this value is true, then we get the first assignment. If this value is false, then we get the second assignment. This is the reason this is called the ternary operator. And as you can see, now TypeScript knows that the value of this bonus can be either 2000 or 3000. Well, TypeScript is not smart enough to know that if I'm passing here for sure a true value, that this should be 2000. Well, TypeScript at this point thinks that this is still 2000. Well, it's not a big deal. And let's now see if we understand how this syntax, JavaScript syntax works. Let's see how conditional types work. And let's take a simple example. Well, here I have a simple example of conditional types. And as you can see, let's not only look at the syntax. The syntax is very similar to the JavaScript ternary operator. Here I have a new type which accesses the salary of a type. This type is called salary of, and usually, and I saw most of the time that the condition that we will put inside our types, conditional types, will just check if a certain type extends another type. This generic type extends another type. In this case, this is our condition, and we will return in this type if our generic type right here extends salary and it has a salary field, then we will return an array of salary. We will return the salary. Otherwise, we will return never. And let's see how this type works, because I've created here another type, an intern type, who in our small company, interns don't have a salary, and let's see if TypeScript understands this. Well, I have created 2 new variables right here, a some salary variable and a no salary variable. The salary variable gets the salary of an employee, and let's see if it understands that this is a number. Yes, this is a number because our salary of employee, it has a salary field. Well, let's see if this salary of intern, if TypeScript understands that this is a never type, and in our company, because it is small, our interns will never have a salary. Yes, TypeScript is smart enough to do this because we use these conditional types. And talking about conditional types, there are multiple ways in which we can put conditions inside our types. Let's see another example. Just as we can have multiple ifs inside a logic block, we can have multiple conditions inside our types. For example, here I'm trying to create a type of array of salaries, which should return an array of numbers. If my type is of type employee, then we should return an array of salaries. Otherwise, we should return an array of numbers. And let's see if this TypeScript understands this, and if we don't pass anything, we should return never. So our employee salaries array should be a number right here. Our simple salaries array should be an array of number. Well, I have a mistake right here. This should be array of the salary like this. And now my employee salaries array is of type number array. Our simple salaries array is of type number. Very simple, and as you can see, in this generic type, I can pass employees or I can pass number. On each case, the output will be the same. If I will add another entry which doesn't contain a salary, let's check it. You see, this no salaries array resolves to this last condition, to the never. The TypeScript documentation shows us another way in which we can use these conditional types. I must recognize that I never used these distributive conditional types, and this happens when we are trying to pass a union of types inside these conditional types or these generic types. And to understand this, let's say that we have this type to array, and this type can either extend any, and we should simply just return an array, otherwise we return never. Well, we can pass this to array and either a string or a number, and this is the point which I want to make. This type string array is either a string array or a number array. Is not an array of string and numbers, and we need to understand this because here we have, for example, a numbers array, and this is of type string or number array. This means that these elements are either numbers or strings. And for example, I can't just say right here number array push a string. This is an compilation error because TypeScript understands that this should be either a number array or a string array. In the same time, if I'm accessing an element of this string or number array, TypeScript will know for sure that this is a number since I initialized it as a number array. Well, we saw in this lecture a few ways in which we can use conditional types. I said I recognize that I never use these distributive conditional types, but the documentation shows us this example, and maybe in your code bases you will find this syntax right here. As a conclusion to this lecture, with these conditional types, you can build very powerful and complex types, but in the same time, you can you can end up with some hard to read types. In this lecture, we will talk about the infer functionality from TypeScript. It is a very powerful but complicated feature of TypeScript, and to understand it, let's first look at a basic JavaScript example. Here we have a function that prints the arguments of an array. To the console, it takes each argument, each element of an array, and it prints this. Fair enough. Well, as you can see, to do this arguments array receives or accesses the for each method of the array, and this for each method requires a callback function. Again, this callback function receives a value, an index, and optionally another array. Well, this argument and index, we are catching them inside the entry of this function right here. Without them, we wouldn't have access inside the body of the function. And this is also the key to understand the infer functionality from TypeScript. We will use infer to go into a type and pull information for another type. Again, infer will let us build types from types, but we can do this inside conditional types. You know, it is complicated, but we will get to a few examples and you will see it's not that hard. Let's take an example. Let's see the following problem. We want to create a type that receives another type and unpacks it. For example, if we are passing a array type to that type, we should get the elements of that array. For example, I have a function, I have a type that is called unpackArray, which receives a type of array and returns back the elements or the type of the elements inside this array. For example, if we are passing this to this unpackArray type a string array, we should return string. Currently, inside this type implementation, we are just returning back the generic value. So currently this sum string type right here is string array, but it should be string. Let's implement this type, this more complex type, and let's do this right now. Well, how can we do this? If you remember, I said that we can use this infer keyword only within conditional types. So let's create a condition right here. I will say right here t extends array, and if that is true, let's just currently return type, return the t, otherwise return never. And you will see this kind of implementation many times when you will use infer, because infer needs to exist inside a conditional type. Well, the last step that we need to make right here is to get the information that is contained inside this array. And we can do this with the infer keyword. So here I'll say infer r or infer anything. It doesn't really matter what you are putting right here. This is basically a newly created variable that catches the type of this array. And now we can return this r. And now if we will look at this sum string type, you'll see that this is of type string. Let's do the same also with promises. Maybe do another example. I have added a new type called unpackPromise, which receives a generic of type promise. Again, let's try to return back what is contained inside that promise. Currently, this returns promise of whatever it contains. Again, let's check this. And we will say right here t extends promise. Make this a conditional type right here. And if this is true, return t for the moment, otherwise return never. Wow, what we have to do right now is to catch the information inside this promise. And to do this, we can use again infer and r, or infer again, whatever you want to put right here. I will put r, and let's just return this r. Now, if we look back, you'll see that again, this sum string type 2 is again string, even if here we are passing a promise of type string. You see, with this infer keyword, now our types are behaving more and more like regular functions, and you can have all kinds of information and all kinds of builds with this infer. Let's see, and let's continue with this example, and maybe let's create one big type right here, one big unpack function, which receives either an array, a promise, or a simple type. Let me do the implementation and then I will explain it. I've created this function unpack, and now it receives anything, even a regular type, an array, a promise, or we can put right here anything, maybe even a function if we want. But what I want to emphasize right here is that now our types are looking more and more like complex functions. For example, in the first entry of this more complex type, we are just making the other check that we did right here, but we are not returning never, we are just proceeding with the other checks. So here we are checking if our function, if our arguments is an array, and if that is an array, we are returning the type contained in that array. The same, we are checking if that type is a promise. Again, we are returning back what is contained inside that promise, or what it should be contained right here. So right here I will say promise of infer R, and let's just return R. And as you can see, I can use the same letter, it doesn't really matter because TypeScript handles this like separate if clauses, so it's no problem right here. And again, if I will look at now at these types, you know, if I pass something that is not handled by the other types, it will just return type. So some unpack of string returns strings, unpack of string array returns string, unpack of promise of string returns string. Let's proceed and see yet another example, maybe with not some unpack but with some regular types. And let's see this infer yet again in action. For example, we have a regular type, the good old employee type with a name and an age. And I made another type that only gets the values of this type and returns back a tuple type. It will return back a tuple containing a string and a number. How we can do this? Again with the infer keyword. And I'm doing this right here when I'm making the conditional type. You will see that I'm checking if type T extends this type, and if that is true, I'm saving what is contained inside that type to this name variable right here and the age variable right here. In the end, I will just return a tuple with name and age. If I will look right here at these employee values, I'm passing down an employee type and I'm returning back an type with string and number, the exact values of this employee type. Let's look at yet another example, maybe the most clearer one inside this lecture. At least I think of that. And let's see the following problem. We have some types inside our code base, and our colleague was having a good time, and he thought that when we are building our positions, I will just put awesome inside in front of each entry inside our positions, because yeah, why not, our company is awesome. Well, our boss doesn't like this, and he wants us to build a type which removes this awesome prefix right here. Of course, we can just rewrite this and everything will be alright, but since we are now have access to very powerful TypeScript features, let's do this with infer. And how we can do this? Of course, the first check is to check that our type extends this awesome. So here I'll say T extends, and let's make a string literal right here, and this T extends awesome like this. And now we can use the infer type right here, and now we can have access to whatever is right here. So here I will say infer R extends string, and at this point we are looking inside the values of whatever is right here, and we are getting back this R. Well, if this is true, let's return this R, otherwise let's return never. Let's see if this is working, and we have this regular position type. Let's see if I will hover over it. You'll see that now awesome is removed from this type, and our boss is now happy. Even if our colleague wanted to make a joke, now our implementation works just fine. You know, this is the power of infer, and we can take this one step further. If we have this remove awesome, we can take this awesome prefix right here and put it also inside our check. And let me make another type right here. Let me just copy this because I'm lazy, and let's just say right here remove prefix, and let's just put this prefix right here, and here I will say prefix and T, and now we should pass this prefix right here. And TypeScript will complain because at this point it doesn't know if this prefix is of type string. So here I will say prefix extends string. Alright, and let's see if this is working. We have this regular position 2, and now we are just removing this prefix awesome from this awesome position. Again, if I will hover over it, you will see that this awesome prefix is removed. Well, we saw in this lecture 3 ways in which we can use the infer functionality from TypeScript. It is a very powerful but sometimes complicated and hard to read functionality from TypeScript, but it will allow you to build very powerful and complex types. The last lecture was very intense. Let's talk about something more easier to understand in this lecture. and also about a great feature of JavaScript which I like very much, the string literals. And in this lecture we will talk about literal types. But first, let's quickly remember what string literals are. We already use them throughout the course. Well, in JavaScript we can easily combine string values or any kind of values into their string counterparts, and we can easily manipulate strings with strings literals. We can do this using the backticks and then the dollar and parenthesis signs, and this way we can easily combine strings. For example, we have a first name, a last name, and then we can easily combine them into a full name with these string literals, and we are getting the full name. Let's see now how TypeScript implements this in its own types, and I'll tell you it is a great feature of TypeScript. Let's say that we have some positions inside our organization, a programmer, HR, and a manager, but these kinds of positions also have different levels. You know, you can be a junior programmer, or a senior, an expert, and you know, we can make different combinations between these positions. Well, we can then write everything by hand. If I want to say that I'm a junior programmer, I can add this to this position and do this by hand, or I can use literal types and combine them together. Well, this leveled position, TypeScript understands this, and it will take all the combinations of the literal types that I've just put right here. And as you can see, we can have a junior programmer, junior HR, and so on, with very little effort. This is a great feature of TypeScript which I love a lot. Another way in which we can use the literal types is by using prefixes inside our types. For example, we can have this prefixed type which takes a prefix of string and a type of string. For example, again, these levels or these positions are a little boring, let's make them awesome. Well, again, instead of writing a new type and manually writing awesome in front of each entry, we can just make this prefix and with textend string, and let's make a literal type, and we have these awesome positions which are awesome programmer, awesome HR, and awesome manager, because our company is awesome. Yes, these are the literal types, a simple but very powerful feature of TypeScript, a feature that won't get your head around very much. And because we have still a little time inside this lecture, let's also talk about some very straightforward utility string manipulation types in TypeScript. TypeScript calls these intrinsic string manipulation types, and this is interesting. This lowercase, this uppercase, this uncapitalized, and also the capitalized type, these are built-in types inside the TypeScript compiler. If I will hover over them, you will see that this doesn't have an implementation, but it is intrinsic. It means that it is built at a lower level to get a better performance, or maybe do something that the TypeScript compiler is not capable on its own. Well, we can see that we can have these lowercase positions, and if I will hover over them, you will see that they are all the letters lowercase. Fair enough, we can have the uppercase position by using the uppercase type, and all of them are uppercase. And maybe uncapitalized positions, again, the first letter is uncapitalized. Well, this is simply the intrinsic string manipulation types, and you saw TypeScript also adds some new features when we are talking about literal strings. Until now, in this section of our course and in the previous one, we saw that we can use different programming topics inside our types. For example, with generics, we saw that we can use types as functions which accept arguments. Also, with conditional types, we saw that we can create something resembling if clauses. And with the infer keyword, we saw that we can save variables inside our types. Well, what programming concept is missing? Well, we are talking about the loops. And yes, we can have loops inside TypeScript types, and we can do this with something called a mapped type. Let's see what they are inside this lecture, and let's see. First of all, let's start with a dump example. Like always, yes, inside our company we have some positions and we have a type position duties. As you can see, at this point we have a lot of two problems inside our types implementations. First of all, we had a lot of code duplication because we have these positions and we have these duties, which is also take those keys from these positions and adds a string array to them. Well, we have two problems. First of all, we have code duplication, and the second problem is that if we will add a new position right here, maybe a Scrum Master, we will also have to keep in mind that we need to add this right here. Well, is there a way in which we can solve these two problems? Yes, with a construct called a mapped type. And the syntax is pretty straightforward. Let's call this a position duties map. And again, this will be a new type. And let's see what we can do. First of all, let's understand the syntax. This is the syntax between square parentheses, and then we are returning something. And let's just say here that we want an array, a loop. So here I can say position in position. And what do we return right here? A string array. And this is basically the syntax of mapped types. What is happening right here? Well, we have this in keyword. This is basically the new thing, and also this square parentheses notation right here. If we will look now over this position duties map, what's the problem right here? Yes, there's a space right here, and then TypeScript won't like this. Let's just leave this like this for the moment. And as you can see, at this point, TypeScript is iterating through the entries of this position literal union type, and it will generate entries inside a new type, entries which are of type string array. Of course, we can take this to the next level and make this position a argument to this position duties map. So let's create a new type right here, which will be a generic. Let me call this like this, generic, which accepts a t. And now we can specify t right here and also maybe key right here. Same more generic types. We have a small problem right here because this t should be of type string, and in order to do this, let's make sure that this t extends string. And now we are sure that this t is string right here. Let's go to the next level and see if we can also make this generic return type right here. For the moment, we are only returning string arrays as values, as types for our keys. Let's see if we can do this in a better way. And to do this, let's remember what a mirror generic would look like. If you remember from the previous sections when we learned the first time about generics, we said that they are receiving arguments to a function. So let me call right here a simple mirror generic type of type t, and this is t. Well, basically this is an useless generic type which doesn't do anything. It just takes an argument of type t and returns back that argument of type t. You know, the blank generic type that doesn't do anything, but what it does a very important point. It lets us understand how the syntax of generics works. The same we can do with mapped types. Let's create an empty map type to understand the syntax. So here I will say type mirror map type, which again receives a t, and let's create this. Let's create an generic mirror map type that doesn't do anything but shows us how the syntax works. So we will go again in the keys of t, but here we have a problem. Let's return something, because this key should be a string, or we should get the key of. So here I'll say key of, and as you can see inside this block right here we have two entries or two variables, the key and the t, and now we can just return t of key. And just like this is a mirror generic type, this is a mirror map type that doesn't do anything. It returns back the exact type that is receiving, but it shows us the exact syntax of our map type. Well, what can we do with these mapped types? Well, we can do a lot of things with them. For example, we can add modifiers to this entry right here. We can make this a read-only entry right here, but we can do more things. And let's see an example. First of all, we will see a dump example, and then we will see a more usual example. Let's see, first of all, a utility from TypeScript called key remapping, a newer function of TypeScript. Let's say that we have a type employee and we want to create a new type from this type that puts awesome in front of the keys of this type, you know, just for fun. How we can do this? We can do something called key remapping, and we can use this syntax right here as, and then we can use a string literal, and let's just say right here awesome, and then let's just get this key right here, awesome, from this key. We have a problem right here because this awesome only accepts strings, and in order to make sure that this key is of type string, we can't just cast it inside this, but what we can do, we can call the intersection or the union of string and key. And let's see if this is working. Let's see if this type awesome employee is awesome of employee. If I will hover over it, you'll see now that we have this awesome name and awesome age from this awesome generic type. We can take the next level, and maybe we don't like that this casing is you know, not the right one. Let's just call capitalize right here, and right here. And now if we look over this type, you'll see that we have the right casing. Well, this was an example in which we can understand how this key off and how mapped types work. Let's see a better example, or a more down-to-earth example. Let's copy this mirror type right here, and let's just make this, let's call this read-only. And the cool thing about this is that we can add, you know, we can add modifiers to these keys. And now if I will make a new type right here, I will say right here type read-only employee is this read-only from our employee. And if I will hover over this type, you will see that now all the entries inside my employee are read-only. We can again take the things a step further. So let's create a new type called mutable right here, and let's just copy this, and you will see it's very simple. Let's call this mutable, and we can take the read-only from these entries with a minus. And now let's see how this is working. Let's create a mutable employee right here, and now even if some entries inside employee, let's make this a read-only. Now this will take all the read-only modifiers right here. Okay, what's the problem? Oh yes, this is a mutable. And now this mutable employee, you will see it will take the read-only modifier from our keys. You know, these utility types, or this read-only that we just put right here, is already built in inside TypeScript. So if I will remove this, you will see I will not have a compilation error, because TypeScript will now resolve to the built-in read-only type. If I will hover over this, you will see that it does the exact same thing. So in TypeScript, using mapped types, there are already some very useful built-in utility types. Let's talk about them in the next lecture. By using mapped types, TypeScript has a few built-in utility types. Let's learn about them inside this lecture. And to illustrate the problem and the solution that TypeScript brings us, let's look at first at this more complicated type employee than before. It has a name, position, a salary, which again has some fields, and then it has some optional fields. Well, TypeScript using mapped types brings us a few utility types. There are many, and maybe you can check the documentation. Inside this lecture, I only want to show you the most usual ones. For example, we have this required employee, which it does what it takes. It takes all the fields inside this employee and makes them required. For example, if you saw before, these likes meetings and teams were optional, now they are all required. That's not the case for intrinsic or more deeper fields inside our object. Well, the same thing, but in the other direction, there's a optional type, you know, this partial employee. And again, this takes all the fields inside our object or inside our types, better said, and makes them optional. As you can see, even if you hover over these types, these are built-in TypeScript types, you will see how exactly they are created. And if you remember, we have this minus sign inside this mapped type, and this just removes the question mark, making the field required. The same with partial. This one adds a new field right here, a new type that this might be undefined. And with read-only, it makes everything read-only. We also saw this in the last lecture. Let's move on and talk about other types of utility types. Let's talk about two new types, the pick and the omit. And they do, again, exactly what they say. For example, here we have a field, a type salary, which is more complicated, and we can extract a new type from this type. Well, there are two ways in which we can extract a type from another type by using the pick utility type. You know, this one takes a set of keys from a type and generates a new type. To be honest, I don't like how this pick works, and you will understand why. For example, here I created a new type called salary pick, but TypeScript is not smart enough to just take only this object as a type and not the whole point. Well, this type right here has also this salary entry right here. I really didn't want it to happen this. There's a better way in which you can extract types from other types, and you can do this directly by accessing them as we would access an array. For example, if we have this employee type right here, let me delete this, and let's try to access all the fields right here like an array. TypeScript even gives us some content assist right here. And now if I look right here, this type salary looks exactly like I wanted. And just as pick takes a information from a type and creates another type, omit takes a type and omits some fields that we want to omit. It does exactly what it says. For example, maybe one good use case for this omit utility would be when we are receiving information as a type from a database or from an API, and we want to change a little that information. We want to sanitize that information. For example, I don't like at this type employee that this employed add field comes as string. Let's say that we would have a function that would sanitize this object and would transform this string value into a date value. And to create a new type from that type, we can simply say here omit, and we can omit the field employed at, and then we can make a union or intersection, better said, with a new type that contains employed at date. Basically, with this approach, we can make any modification inside our types. You know, this doesn't have a preview, but this way I changed this employed at field from string to date, and I did this with the omit utility type. And there's one last utility type which I want to show you. Again, I've used it many times and I find it very useful. For example, we have a function inside our code base or inside our class, inside our file, which returns a complicated object. Well, one way in which we can reuse the structure of this return type is by using the return type utility type. And what this does, it takes usually we use it with an argument of type function, but in order to use it we need to specify the type of keyword. And now we have a new type called old position or whatever you want to call it, which has the exact structure as the return type of our function. And this way we can reduce code duplication inside our code base, and also if something changes right here inside our very important function, the type will be directly updated. Well, these were just a few of the utility types that are existing in TypeScript. You can check the documentation, I will link it inside the lecture, to find all the utility types that TypeScript gives us. In this lecture, we will have a little practice of creating some advanced types with the informations that we received until now in this section. And I want to start this lecture by showing you this very cool repository called Type Challenges. And this is a repository which contains a lot of great TypeScript types exercises. There will be a link in the resources of this lecture. And if I will go downstairs, you will see that this repository contains some challenges based on a level, like a warm-up, easy, medium. If we go down, we can see there are hard and extreme challenges. Basically, we can build some advanced types with generics and with the other techniques I showed you inside this section. Anytime you like, you can take these exercises. If you will click one of them, it contains the challenge and it also contains a link to its solution. And just as a simple exercise, let's do two challenges inside this lecture. Let's implement ourselves a custom pick type. For example, there's already a built-in pick type inside TypeScript. Let's build ourselves the same type. And we will always start, or most often start, from these mapped types. If you remember it from the previous lectures, this is the way we can iterate through the keys of a type and return something else. This is the mirror map type, mirror map type that doesn't do anything, but it's a starting point for us when we want to create a new type. Well, I said we want to implement ourselves our own pick. So I will start to implement it, and this is the starting point. At pick elements we are receiving two parameters, this my pick. First of all, it receives the original type and then the keys that we want to use. The first thing that we need to know is that the second key should also always be a key of this t. So this key should extend key of t. We should always use this pick based on the keys of our original type. Then we simply use a map type right here, and we want to say that our key inside key, this one, this will be our key, and then we simply return the object at that point. And basically this is the pick type. Let's see if this is working. For example, I have this constant called name and age, and I'm using this my pick. I'm passing an employee, and then I want to take from it the name and the age. If I look at this my pick, you will see that this name and age contains the name and the age. So my pick works just fine. Well, let's do a more complicated example. Let's take another example. I find very interesting if we look at the repository, I find very interesting this deep read-only custom type. It is really a great exercise with many solutions and many problems along the way. I will just present you a very straightforward solution. Basically, we already know how to create a read-only type. We saw it in the previous sections. So if I will again start from this mirror map type, here I can say type my read-only and make this a read-only field. And basically now, if I will want to have a read-only employee, I will say right here my read-only. And if I will look at the elements right here, you will see that all its keys at the first level will be read-only. Well, this is just half of the solution. If you look at this salary type right here, at the salary object, the contents of this salary are not read-only. Well, how we can fix this? And I want to tell you that TypeScript supports recursion inside its custom types. Yes, that's a great feature of TypeScript advanced types. So let's implement our own deep read-only, and the starting point will be exactly like this. So here I can say this type is deep read-only, and basically it should work recursively. If I will just take the name of this type right here and put it in the element that we are returning, theoretically this should work. Of course, here I need to pass this key as a generic to this deep read-only, like this. But if we look now, if we want to test this, and I will say here deep read-only, you'll see that again this is not working because this deep read-only is not able to go inside this nested type. Well, we need some way to stop this iteration of when the keys end of this type. Well, how we can do this? We need somehow to stop this iteration, as I said, and we will stop this iteration when we end up in a never type. And the solution to this problem was this, let's say, flow control check right here. If the key of t extends never, basically we are reaching the deepest point inside the object, then we are simply returning t. Otherwise, we are returning this read-only type. If I will save this, let's see if now this is working. Yes, now also our nested properties are read-only, so this means that this type works. Well, it only halfway works. If, for example, a key of this employee will be of type any, then things will not work so well anymore. You'll see now that this amount will be something of a variable type, which is not okay. So this implementation of the deep read-only doesn't work well with the any type. Well, I let you check the repository and see what solutions are presented right there. For the moment, I wanted to show you that there are great places in which you can practice these advanced types. Well, we reached the end of this section where we talked about some advanced types. Let's move on into the next sections and talk also about some advanced or fundamental JavaScript features that you will need when you program with TypeScript.